for the record, this is the second time I'm doing this, so I am definitely paying my dues on this one. So this morning, it's Friday. There were not too many of you, but a few of you who joined me, and I was recording as we were doing the review sheet, and I was hoping to kill two birds with one stone, but guess what happened? When I ended it and I looked at it, what do you call it? At some point, it stopped recording, so I have to do it all over again. Well, we'll do it quick. I'll try to do it quick. Less than an hour, I hope. So hopefully you did this, or you're taking your time. Friday, Saturday, Sunday night. You've divided this into 3 parts instead of doing all at once. So let's start with the easy part. Find the circumference. So anytime you want to find circumference, I mean, some of these you can even skip, I think. You get 24/3 pi, right? Because you're multiplying by pi. Find the circumference of a circle with the diameter is 24, so that will be what you have. Make sure you get the units. I am leaving everything in terms of pi because I'm going to be really lazy. But if your multiple choice on Monday was a numerical answer, then you would multiply 23 times pi and you'll be okay. Okay. So again, here we're given the radius. So if the radius is 9.5, and again, you can use this one if you like. I just don't. Never bother with that, so I just use C equals pi d. And if I know that the radius is 9.5, the diameter is obviously 19, and like I said, I'm going to leave everything in terms of pi. Okay. Number 2, find the diameter of a circle if the circumference. So we're going backwards here, so C equals pi d. The circumference is 36, and we have pi d here, and we're going to divide both sides by pi. And in this case, 36 divided by pi is some number. Diameter is 11.5 inches. Okay, rounded. Again, C equals pi d. We're going to find the diameter and then divide it by 2 to find the radius. So the circumference is given to us. I'm going to divide both sides by pi. So the diameter itself is 25, so the radius is 12.5. Find the area of a circle. So again, this one is, we're going to obviously use pi r squared. This one's straightforward. And 5.5 to the second power is 30.25. Let me just rewrite this a little better. It's 30.25 pi, and if I'm leaving it in terms of pi, make sure you choose centimeters squared. F area equals pi r squared again. The diameter is 18, which makes my radius 9. So this ends up being 81 pi. What's the meters squared? Okay, 9 to the second power is 81. H. H says find the radius given the area. So again, okay, so this one we're solving for r instead of a. 225 pi equals pi r squared. These two can go away, right? We divide both sides by pi, so those will go away. We can take the square root now of both sides. And we get that r equals 15 feet. This one's the same thing, except that we want the diameter. So once we find the radius, we just multiply by 2. So we're given that the area is 52.8 equals pi r squared. Let's divide both sides by pi, right, in this case. So that goes away. And 52.8 divided by pi equals 1681 rounded. Okay, I'm gonna round. I shouldn't round right now. I just don't know how to do the calculator where I take so the answer in the calculator is 16 point, and again, 806766199, and goes on forever. So I don't know how to press the square root so that it takes the square root of that number instead of rounding it and then taking the square root. So because I don't know how to do that on this calculator, I'm gonna round it, and then we're gonna take the square root. Right? If I figure it out at some point, I'll let you guys know. So if you take the square root of both sides, you get that 4, what do you call, the radius equals 4.1, and because we want the diameter, it's 8.2. we want, so this one, we want the circumference, but we can't find the circumference because we don't have diameter, so we're going to use the area formula to find the radius, to then multiply by 2 and find the, we call diameter. So here's my area, 144 pi equals pi r squared. These 2 pi can go away. Take the square root of both sides and we get that r equals 12. Therefore, the diameter is 24. And if we multiply here, we get 24 pi meters, right? That's it. Again, if you want to continue, you can multiply 24 times pi, which is about times 3, so about 75 something, somewhere around that line. Find the circumference of the circle. If the area is, so this one is the same problem, except the area here is in numerical, it's not in terms of pi, so we actually have to divide it by pi. So 320 divided by pi, 320 divided by pi equals 101.86. And we're going to take the square root of that, So 101.86, square root 101.86. That's going to give us just about 10.09. So the radius is 10.09, and then therefore the diameter is going to be 20.18. And I'm going to again leave it in terms of pi because I'm too lazy right now to multiply it out. And 20.18 pi meters, right? So you can multiply that at your own leisure. L, find the circumference, find the area. Okay, again, so we need to find the area of a circle. Well, we don't have the radius, so but we're given that the circumference, right, is, so this is 145.24. So therefore, we can find the diameter and divide that by 2 to find the radius. So let's divide both sides by pi. And then we're going to get the diameter, 145.24 divided by pi. It's going to be 46.23, 23 dot 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 continued, by the way. Okay, so which makes my radius, and I'm going to divide that by 2, whatever my calculator here. And if I have to round that, it would be 23.12, the radius. So A equals pi times 23.12 to the second power. And I'm going to take that, 23.12 to the second power. So A equals 534.53. I'm going to leave it in terms of pi inches squared. Okay, so depending on how you round it here, we might be off by a little bit here. Okay, but as long as you're in that vicinity. Okay, so now again, we want to find the area of a circle. We need the radius, but we know the circumference. So let's use the circumference formula to find the diameter, which is, so the circumference is 81 pi d, divide both sides by pi, and 81. So the radius is 40.5. So area equals pi times 40.5 to the second power. And again, we're leaving that in terms of pi. And that's going to be, the area is going to be 1,640.25 pi meters squared. Okay. So again, so these first problems were pretty straightforward. We want the perimeter of this shape. So the perimeter again is, you know, the distance around. So if you have to take a nice little walk over here, right? If you have to take a walk, what's the distance that you just covered? So let me see what I have. I know that that's 10, so it makes this 10. Oops. Which makes this guy 10, 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 and this guy 10. So I need that curvy part, right? And that curvy part represents 1/4 of the circumference. So if this is a circumference of a circle, that curvy part over there is this right here, right? So 1 full lap is a circumference, but we're not taking the full lap around the circle, so we just need 1/4 of the circumference. So if you find the circumference and divide it by 4, we'll know exactly how much that little curvy part is. Okay, so circumference, C equals pi d. What's the diameter? So again, this here, right here, so that's the radius, that's the radius. So if the radius is 10, right, that means the diameter is 20. So C equals 20 times pi. C equals 60 something, right? 20 times pi equals 62.83. 62.83 is the full lap, right? So imagine if that was a circle. Let me just draw it. Oops, make a better circle. So if that was a full circle, right, that's a little better. And if you walk the whole circle, it'd be 62.83 centimeters, but we're not interested in that. We divided that by 4, and I'm going to take that. So this is actually 15.71. Okay, so then we have 10, 20, 30, 40, 50, 60. 60 plus 15, 75.71 centimeters. So we want the distance between these two lines, the outer circle and the inner circle. So there's a radius here, right? And we can put that. So the radius, so the distance, that green line here is going to be the difference between that. So again, that's the radius of the small circle. Let me draw the radius of the big circle. Right? So if I do the blue line and I subtract this red line over here, won't I be, this one, isn't this the leftover part? Leftover? Right? So I need to find the radius of the small circle and then radius of the big circle and subtract one from each other. So in this case, the big one, I'm giving that the circumference is 48. So let's do that. 48 pi d. So we're going to divide both sides by pi. And diameter is going to be 48 divided by pi. Oops. 48 divided by pi. Enter. And then we're going to divide that by 2. So the diameter is 7.6394, blah, blah, blah. So I'm just going to take that and divide it by 2 again. So my radius, wait, hang on a sec. 48 divided by pi is going to give me 15.27899, right? So let me write the diameter. Sorry. The diameter of that circle is 15.27, blah, 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 blah. I'm going to take that number and just leave it in the calculator. I'm going to divide that by 2. So which means my radius is 7.63. So the radius of the big circle is 7.63. Now the small circle, C equals pi d. The circumference of the small circle is 12 centimeters. So we're going to divide both sides by pi again. And d equals 12 divided by pi, which is 3.81, blah, 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 blah. So I'm going to leave it like this for now, 3.81. And I'm going to take that and divide by 2. So the answer that's in the calculator, divide that by 2 to get my radius, a more precise radius. And I'm going to get that the radius is 1 point, and now I'm going to round 91. So we have 7.63 minus 1.91, and that should be the leftover part. So 7.63 minus 1.91 equals 5.72. Okay. P. So we want the, what do we want here? What's the area? Oh, so we want the area of this shape. So the area of this shape is the semicircle plus the rectangle. Rectangle is easy enough. It's 300. Okay, so I'm just going to write 300 in the box, centimeters squared. So I'll do the units later. Semicircle, so area equals pi r squared. So area equals pi, and what's the radius of this circle? The radius is 15, right? So it's 15 to the second power. So it's 225 pi, but I'm going to multiply that out. 225 times pi. So the area of the full, if it was a full circle, would be 706,858, blah, 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 blah. I'm going to divide the answer in the calculator by 2. It's going to give me a more precise answer. So my area of a semicircle, right, so the area divided by 2, is going to be 353.43. The area of the circle divided by 2, so I take that out. Here, put it over here, divided by 2. So the area here is 353.43 and etc., right, going on. So if we add those two, you can clearly tell that the correct answer is going to be B. So here's a car tire. The radius is 22 inches, which makes the diameter, oops, let me draw a better circle, sorry. So car tire, radius is 22. If the radius is 22, automatically can draw the diameter and call it 44. So it says here that we're asking for how many revolutions must this tire do in order to travel 150 feet. So let's first of all change 150 feet to inches. So let's multiply that by 12. We get that it's 1,800 inches. So imagine a car tire and it starts here. So every time it spins, right? So every time it spins, it travels a certain distance, right? And then it spins again and spins again. So every time it spins one revolution, how much does it travel? So, and the distance traveled would be your circumference. So let's find our circumference. C equals pi d. C equals pi, and the diameter we know is 44. Let me multiply that out. 44 times pi, and I get that the circumference is 138 inches, 0.23. So every time this tire does one revolution, it travels as much. But I want to know how many revolutions you need to travel 1,800 inches. So 1,800 divided by 138.23, and we're going to get, so 1,800 divided by 138.23. So we need this tire to go 13 full revolutions and just a little bit more of the following one to reach 1,800 inches. Okay, so that would have been your answer. Okay, so this one, a little repetitive here. So let's do the perimeter first. So this is 7, that's 7, and we want that. So this part that I'm highlighting right here is half of a circumference, right? Half of the circumference of that circle. So I need to figure that out. So C equals pi d. Circumference equals pi, and we have the diameter here, which is 12. Let's multiply that out. 12 times pi equals 37.70. So this part right here, half of the circumference, is 37.70. So if you're going to take a nice walk around this shape, right? You're going to take a nice walk around the shape. You're going to walk, well, 21,777 plus 3770 is 21 plus 3770, which is going to give us 58.70 centimeters. So that's the distance around this particular shape. The area, I think it's easier. Area is the area of this rectangle at the bottom and the area of a semicircle. Well, so this is half a circle, right? The top, half a circle, right? Area, half a circle. So let's do the rectangle. The rectangle is easy. It's 7 times 2, 84 centimeters squared, right? The area, it's a rectangle, base times height. The area of the circle on top is going to be area equals pi, and the radius is not 12, but 6, right? So it's 36, or better yet, let's multiply 36 times pi, and we're going to get 113.10 rounded. So if we add 113.10 plus 84, 113.10 plus 84, we're going to get that the whole, oh, sorry, I forgot to divide the area by 2. So let me go back. That's wrong. So the area of the full circle is 113 divided by 10. 113.10. So 113.10 divided by 2 is going to give me 56.55. And that's the area of a half a circle. So half. Right. So now let's add 56.55 plus 84, which is the area of the rectangle. And we're going to get that the combined area is 140.55 centimeters squared. Okay. Let's do the perimeter. Again, the perimeter in this case, this one is easier, right? Because the perimeter we have half a circle here and half a circle here. So if you're actually walking this, you're going to walk 8 centimeters here. You're going to 8 centimeters, but this half a circle and half the circle becomes one full lap around a circle, right? So C equals pi d. C equals pi times, and the diameter is 6. So let's multiply 6 times pi, and we get, we get that C equals 18.85 centimeters, and we're going to add to this 8 and to this 8, right? Because we're going to now walk the whole thing. So 18.85 plus the 8 plus the 8 is 16, and that's going to give us 34.85 centimeters to take a walk around this shape. The area again is, the area of the rectangle, which is 48 here, base times height. And in this case, we don't have to divide anything by 2 because this part and this part make one full circle. So A equals pi r squared. The radius is not 6, but it's 3, so it's pi times 3 to the second power. And I'm going to multiply my calculator 9 times pi, and that's going to give us 28.27. So if I add the 28.27 to the 48 of the rectangle, I'm going to get 76.27 centimeters squared. Right? So it's the combined area of the rectangle plus the area of the circle. All right. Those are just annoying to do. That's all there is. So again, this one, first time I did it early in the morning, I messed up. Well, I learned my lesson. So here's 4, right? So this is the radius. Again, imagine this is the center of the circle. So this is 4. Guess what? This part right here is also 4. And if that's 4, it makes this bottom part 6. So now this is 4, that's 6, and this is 6, this is 4, and this is 4. Now, let's find the distance around this. So we're going to walk around this shape. So to walk around this shape, our components are a 4, a 6, this curvy part, and this curvy part, right? And then let me put the 6 and 4 first. 6 and 4. So, and then we have curve and a curve. If I add all those parts, it gives me the perimeter of this shape. So, but this curved part and that curvy part, right? It makes it makes half a circumference, right? Because those two parts make up half a circle. So let's find the circumference of a full circle first of all. C equals pi d. Circumference is pi, and the diameter. Well, we know the radius is 4, so the diameter is 8. So 8 times pi is 25.13. So the circumference of that circle is 25.13. So if that was a full circle, so we're going to divide that by 2, and we're going to get that C equals 12.57. So I'm going to remove this part, curve. So those two curves, and I'm just going to put it on the side here, and those two curves make half a circle, half the perimeter of a circle, which is 12.57. So let's add everything else. So that's a 10 plus a 10, that's 20, 32.57 is my final answer for the perimeter. My area, we have an area of a rectangle here, 4 times 10, so this is going to be 40. And this, with this, make up a semicircle, half of a circle, right? So the area of a circle, of the full circle in this case, is area equals pi r squared, or pi times 4 squared, which gives me 16 pi. We're going to actually, 16 times pi, numerically, the area of the full circle is 15.27. But because I'm only interested in half, right, I'm going to divide that by 2. And I'm going to get my calculator 25.13. So this make half a circle, and this is half a circle, 25.13, and then we're going to add that, so 25.13 plus the 40, which is a rectangle, which gives us 65.13 centimeters squared. So here we have a big circle. So imagine you had a full circle and you punched 2 holes, a medium-sized one and a small one. Whatever's left over is the part that we're interested in. So the area, so let me just continue this. That would be 3, right? And this would be 2. So the big circle, the area of this circle, and we're going to leave this in terms of pi. It's pi r squared. So what's the radius of the big circle? Well, the radius of the big circle, well, the diameter here is 3, 6, 8, 10. So the whole line is 10, right? From here all the way here is 10. So if the diameter is 10, the radius is 5. So we're going to go pi times 5 squared, which is going to give us 25 pi. Okay, so the area of the whole circle would be that. Now, the medium circle, which is the one with the 3, a equals pi r squared. In this case, the radius of that circle here is 3, so we're going to get pi times 3 squared, or 9 pi. I'm going to leave it at that. The small circle, again, pi r squared, and a equals pi, and the radius of the small circle is 2, so that would be 2 squared, which is it's going to give us 4 pi. So here's my big circle. I'm going to take out 9 pi, and then I'm going to take out 4 pi. So what do I have left over? I'm going to have something pi. 25 minus 9 is, I don't know, what is that? 16, and 16 minus 4 is 12. So I'm left with 12 pi. What's the units? Units squared. Okay. Oh, okay. So this one again. This one's a little tricky, right? Because again, we want same deal. So let's find the area of the big circle. The area of the big circle is going to be, big over here. It's pi, and what's the radius of the big circle? The radius of the big circle is from here all the way to here. I know this part is 13, right? Because that's the radius, half of the diameter. So which means this part is 13. Now how much is this part? It tells us right here, 7 centimeters. So the radius is 20 centimeters. So we're going to leave it like that. So a equals 20 pi whatever units squared. The small circle, that's the easy one. Again, a equals pi r squared. Pi, and the radius of the small circle, well, is 13. I'm going to leave that again. Oops, 20 squared, so this should have been 400. I'm sorry. So I should have written 400 pi. This one is 13 squared. 13 squared is 169 pi centimeters squared. So all we have to do is subtract 400 pi minus 169 pi, and we can treat the pi as a variable, so that's going to stay, and just subtract 400 minus 169. That's going to give us 231 pi centimeters squared. Okay. The area of the rectangle is 12 squared, or 144, so that's easy. Minus, we got to find the area of the circle. Well, the circle has a radius of 6, right? Because the diameter is 12. So pi times r squared, or 6 squared, or 36 pi, and that's going to give me 113.10. So I'm going to subtract 113.10 because that's the area of the circle. So 144 minus 113.10 is 30.9. So the shaded region that's left over is 30.9 centimeters squared. Okay. Now I'm doing it fast, but since you guys can stop and just replay it. It's not a big deal. So okay, that was the first session. Okay, now the second session comes. I think it's even easier. Heron's formula, etc., and all that stuff. So here we had a triangle, and initially the triangle, and I'm just making this triangle up. So 3, 5, 7. So it was a 3, 5, 7 triangle, right? And if we go back to ratios, right? So here's the ratio of 3 to 5 to 7. This is let me write it over here because you can see it. Actually, I can write it over here because I can do this. So let me draw everything again. So it's 3, 5, 7, and I'm just making the triangle up, so don't. So here's a triangle 3, 5, 7, and then currently 3 to 5 to 7. So this is the part. And what's my total? My total is 15. So when my sides are 3, 5, and 7, my total is 15. So we can sort of find our dimensions of my new triangle. So when my perimeter is 300, what are my new sides of my triangle? So imagine now that the triangle got bigger, right? We drew a bigger triangle, right? Proportional. So 15 times what's 30? It's times 20. So we're going to take and multiply everything times 20. That's going to be 60, 100, and 140. I'm going to call this 60, 100, and 140. And that's what we're going to, and that's what, and that's the triangle we're going to work with. Okay, but we needed to do that. So Heron's formula says we have to take the semi-perimeter, right? So we're going to add 60 plus 140 plus 100, and then we got to divide that by 2, right? We have semi-perimeter. 200, 300, 300 divided by 2 is 150, right? And then to find the area, I'm going to take the square root of 150, and we're going to subtract 150 minus each of those sides. Minus 140 and 150 minus 100. So we're going to get 150 times something times 90 times 10 times 50. I'm going to take the square root of all that. So just plug that in your calculator. 150 times, and we're going to take the square root of that. With a nice, pretty number. No. Ugh. No, I'm missing something. So 150 times 90 times 10 times 50. What am I doing wrong? Thought it was a nice number. I guess it was not. I guess it's not. Okay. All right. So 150 times 90 times 10 times 50 equals. I'm gonna take the square root of 670. What? 4 zeros. Yeah. Take the square root of that. 4, and it's going to give us 2,000. So the area of this is 2,598.008. That's the unit. Unit is meters squared. Okay. This is actually a really nice problem. I mentioned this in the morning. So we need to find the area of this triangle, and we need to find the area of the triangle. So the area of this triangle is the easy one, right? Because it's 90 degree angle triangle. We can just use base times height divided by 2. So base is 9, the base is 40 times 9 divided by 2, right? And we're going to get that it's 180 meters squared. So that's already taken care of, right? So 180 meters squared. Now the other triangle, we're going to use Heron's formula again, but in order to do Heron's formula, we need this side over here. We need to work out this side. And in order to get that side, we can use the Pythagorean theorem, right? Because that's the side that's missing over here. So let me just draw that. It's curving. Okay, there you go. Well, there. So, oh my God. Okay, a little better. That's the 9, that's the 40, and we need to find the hypotenuse, the length, so we can use Pythagorean theorem. Right, so we gotta go c squared equals 81 plus 1600. C squared is 1681. We're gonna take the square root. Let me just write that down. 1681. We're going to take the square root of that, right? And square root of 1681 is going to give us 41. Oh, that's the pretty number. So that's 41. So we already know the area of the triangle on the bottom side, which is 180. Now I can finally find the area of the triangle at the top. So again, we need to find the semi-perimeter. So we're going to add 28 plus 41 plus 15, and we're going to divide all that by 2. And hopefully that's a nice number. 28 plus 41 plus 50. 28 plus 41 plus 50. Oh my God. Should take a lesson on how to use a calculator. Divided by 2, it's 42. So the semi-perimeter of that triangle is 42. And then we're going to use Euron's formula. And the area is going to be 42. And we're going to take 42 and subtract it by 28. 42 subtracted by 41, and 42 subtracted by 15. Okay, so square root of 42 times, and that's 14, times 1, and then 27, right? So let's multiply 42 times 14 times 1 times 27, which is going to give us 15,876, which we can now take the square root. And wow, the area is a nice number too, 126 meters squared. So the area of that triangle, let me just erase this 41 because we don't need it anymore. So the area of this triangle is 126 meters squared. So if we add those two, 180 plus 126, we get 306 meters squared for the combined. So there's quite a lot of things you had to do. Well, you had to use just your formula for area of a triangle given the height. You have to use Pythagorean Theorem, and you have to use Euron's formula. So this was a nice problem. Hint. I think we're doing laws of cosine now. So what I'm going to do is see, we can use ac squared equals a squared plus b squared minus 2ac and cosine of c, right? So who is a, who is b, and c? Well, c is the one that has the answer. Let me call this angle c. Let me call this a, and let me call this b, which make this little b, little a, and little c. Okay, so c squared. Oops. No. What's going on here? Yeah, guys. No. Okay, so let me go a little lower. All right, that's what I want to do. So I'm going to substitute. So I'm going to get c squared, which I don't know, right? I need to find the length here. So c squared equals a squared, and middle a is 9.9 to the second power, plus b, which is 6 to the second power, minus 2 times 9.9 times 6, and then cosine of 114 degrees. So c squared, 9.9 to the second power, 9.9 is 98.01, plus 36 minus, and let's multiply all that. That's 2 times 99, 2 times 9.9 times 6. Sorry, I have to use my phone in order to do that. 2 times 9.9 times 6 times 114 cos, and that's going to give us equals negative, so I'm going to write that number down, negative 48.32. Right, so now if you continue this, let's do so negative and a negative. This is eventually going to give you a positive, right? So let's add all that. So it's going to be 98.01 plus 36 and then plus 48.32 equals to 182.33, which we now can take the square root of. And the square root of that particular fellow, 33 square root 182. 182.33 equals, so C, our mystery side C, equals 13.50. Okay, so I guess the big problem in this question would be knowing that your answer here was a negative answer, so a negative and negative will eventually become positive. Okay, so just careful with that. So I'm in morning here, I didn't read it, and it says find angle X. So this is the angle, and I'm going to call it theta over here. Okay, angle theta. Actually, angle. So I'm going to call it angle. I'm going to call it angle. Okay, angle X will be C. This is little c. This is A. This is little a. This is B. This is little b. And the only reason I did that is because I just like to use this one, right? I mean, c squared equals a squared plus b squared minus 2ab times cosine of, and then in this case cosine of c of the angle that we need to find. I mean, remember, you can use this, right? Depending, so you could have called that a, I made this little a, so it really depends on how you shift it over. It's really the same thing. So let's do this. So c squared would be 8 squared. Little a is 6, so it's this. Little b is 9, so it's 9 squared. So we're going to multiply 2 times a, which is 6, times b, which is 9, and we're going to find the cosine of c, which is what we want, right? Angle c. I'll call this even big C. 64, 36, 81, and this is going to be 2 times 6 times 9, 2 times 6, oops, 2 times 6 times 9 equals, I'm going to leave this as 108 cos of C, right? So what can we do? We can throw this guy to the other side, making it positive. And we're going to 64, I'm going to throw 64 to that side, right? Subtract both sides by 64, so I'm going to have 36 plus 81 equals 117 minus 64. That's going to give us 53, right? So all I did was throw this to the left side, and then I threw this to the right side, but when it comes to the right side, it comes as negative. So now we have that, and what I can do is divide both sides by 108, so little by little. Right, so I'm going to continue over here. Cos of C equals, what's 53 divided by 108? 53 divided by 108 is some big number, 0.4907. 07, and I'm not going to write the rest, but I'm going to leave that in my calculator. So remember what the next step here, right? We want to isolate C, our angle. So we got to multiply this by this, cosine negative 1, and on the other side, cosine negative 1. This and this goes away. C is left over, so that 0.4907, 407, 407, etc., etc. We're going to just press and find the second function, right? And we're going to do cosine negative 1. And we get that our angle C is 60.61. Okay, and that's all we have to do for that particular problem. This looks like, oops, looks like something signed. Lost sign? No, don't do that. allows me, sorry guys, to do this. Open up. All right, so we want to do law of sines here. And we do law of sines because it's easier. And you can change this to ABC if you like, or leave it as QPR, the same thing. So I'm going to leave it as QPR. So I'm just going to call this little p. This is going to be, and that's all I have, little p. So, you know what? Keep it consistent. Let me just change this to ABC, okay? I'll call this little a. So, A sine of A, remember? B sine of B, and C sine of C. So let's fill it in. So A I do have, it's 4, sine of 105. B, I have the angle, but I don't have, so sine of 51. And C, I do have the angle, which I forgot to do. I don't have this length. So angle C here, well, we know that in the triangle, all the angles add up to 180. So we have 180 minus 156. So this angle right here is 24 degrees. All right, so we can write sine of 24. So A is the only one that has, what do you call, both values in the numerator and denominator. So I can use that as my base to use do the proportion, right? So let's do these two right now. So cross multiply, I'm going to get sine 105 times B and 4 times sine of 51. B is what I want in this case, right? So B here. So let me divide this by sine of 105, which means I have to divide this by sine of 105. That goes away, and my little b. So in your calculator, I'm going to do, let's see, I have to do 4 times 50, oops, 4 times 51 sine equals, so my numerator becomes 3.1085, and I'm going to leave it like that. That's my numerator, so just so that you can double check. And then I'm going to divide that by sine of 105, right? So I did that top, and then now I have to divide that by sine of 105, and I'm going to get some divide sine, and I get 3.22 rounded, okay? So little b here is 3.22 centimeters, okay? So I can come over here where little b is here, okay? And I'm going to replace that with 3.22. No, not there. Right here, sorry. I'll call this 3.22. So again, now I can I can either pick A or B to help me to find, to set a proportion with this guy over here. So again, I'm just going to use A because B has a decimal, so I'm just going to use 4 sine 105. I'm going to use that with C sine of 24. So again, it's the same thing. Cross multiply, we're going to get sine of 105 times C equals 4 sine of 24. So let's divide both sides by sine of 105, right? And we can get our, what is this, our little c. So little c, so let's multiply that out. So I'm just going to do the whole thing. 4 times 24 sine equals 1.62. Now I'm going to divide that by 105 sine. That gives me, for me, 1.68, what is it, centimeters? Centimeters. So little c here, which is this guy over here, is 1.68, rounded. Okay, so that's law of cosines. Again, we have two angles. Let's add it up. 109 plus what? 26 minus 180. That missing angle is 45. So we take care of that guy already. So let's set up our law of sine, and honestly, it doesn't really matter. If you want to keep it f, d, e, df, you can keep it df. I'm going to call this a, I'm going to call this b, I'm going to call this c. Okay, so that so sine of a, so again, little a, little b, little c. So I'm just going to write what I know. So a over sine of 45, b, which is 8 over sine of 109, and little c, which is, I don't know, and sine of 26, which is this angle right here. So obviously, this is my go-to person. So I'm going to set up a proportion between that one and this one right now. Let's cross multiply. So I'm going to get sine of 109, C, right? And then 8 times sine of 26. Divide by 109, sine of 109, sorry. Divide this by sine of 109. So again, you can tell it becomes repetitive. So this goes away. So in your calculator, 8 times 26 sine equals, 8 times, and then that gives you 350, 351 rounded. I'm going to leave it in my calculator. I'm going to divide that by, is that 10? No, 109, sorry. 109 sine, and I get 3.70. So C here is 3.71, sorry, 3.71. Okay, so that's 3.71. I'm going to change here. I'm going to write 3.71. You're welcome to use that part now to set up a proportion with this guy here, but I'm just going to use these two. So again, 8 times sine of 109, cross multiply. 8 times sine of 45. Right, we want to find A, so it has to look like this. So in order to look like that, we're going to divide this by sine of 109 on both sides. That goes away. 8 gets isolated, and let's put that in the calculator. 8 times 45 sine gives me 5.65 or 67, and divide that by 109 sine. That's going to give us 5.98 rounded. So little a is 5.98. So there you go. Okay. Find the missing sides and angles. So this is a right angle triangle. If it's a right angle triangle, we're gonna use your favorite. Really, really, really easy. SOHCAHTOA. Okay, so let me give myself some room. So on this one, we want to find all of them, right? So it says, so let's start with A. It says find the missing sides and angles. So let's find A. So based on this angle, based on this angle right here, that would be my opposite. That would be my hypotenuse, and this would be my adjacent, right? So in order to find the opposite here, who can I use? Let me rephrase that, because that's not what I meant. I need to find angle A first. And in order to find angle A, I can use adjacent and hypotenuse, right? Because those two I have the value. So adjacent and hypotenuse means I use cosine. So and let's call it so the sine of A, angle A, is the adjacent, which is 5, over the hypotenuse, which is 19, right? So let's divide 5 over 19 in that calculator. 5 divided by 19 is 5 divided, you know what? So we get 0.26315, blah, blah, blah. So I'm just showing you what you get. So that's the ratio, right, of 5 to 19. So 5 over 19, that's a decimal, 0.26315, blah, blah, blah. So now we're going to multiply this side by sine negative 1 and multiply this side by sine negative 1, right? So this and this goes away. Our angle A gets isolated, and then just kindly, hopefully, still have this in your calculator, and just go find the second function, sine -1, and we're going to get that that angle is 15.26 degrees. So once I have that angle, find the other angle. It's not that hard because it's just, well, this is 90, 15.26, and then that's just going to be the difference, right? So, and that angle over here is 74.77. So let's keep that. Let's use this. So let's use everything in terms of this angle, 15.26. So how do I find the opposite side of that? So to find the opposite, I can use TOA or I can use SO. So sine of 15.26 equals the opposite, which is, I don't know what it is, over the hypotenuse, which is 19, right? So multiply this by 19, multiply this side by 19. So that 19 and this 19 gets, simplified to 1. So the opposite side is it's 19 times sine of 15.26. So 19 times sine of 15.26, that's going to give us 5. So the opposite side over here can't be 5. What did we do wrong here? That's okay. So opposite over hypotenuse. Did I multiply something wrong? Times 15.26 sine equals 5. So the opposite is 5. That can't be. Oh no. Oh, it's getting late. What am I doing wrong? Did I find 15.26 wrong? Oh, I'm gonna start all over. So let's try to find angle A. So this is the opposite side. This is the hypotenuse. And this is my adjacent. So let's find angle A. Don't find angle A. What relationship can I use? So, ka or toa. To find the angle A here, I'm going to use the two sides that I know, the adjacent and the hypotenuse. That means it's cosine. Was I using, okay. Ooh, there is my, so cosine of A, no, cosine of A is a hypotenuse, which is 19. Cosine of A, which is adjacent, sorry, over 19. So that's correct. That's correct, I remember. So it's 5 divided by 19 equals, no, 5 divided by 19. 5 divided by 19, and then we're going to take, 5 divided by 19, and then, cos of A, which is 0.263, blah, 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 blah. We multiply it by cos -1, and angle A is second function cos -1. That's a better answer, okay, 74.74 degrees. Now that makes sense. Okay. All right, so I made a mistake somewhere. I think I used sine instead of cosine. Okay, my apologies. So that angle is 74.71, 74.74 rounded, and then we're going to use that same angle to find the opposite side. So what can I use? Is there anything that uses the opposite? I can actually, because I have every other value, I can use any. So let's use tangent because we have tangent. So tan of 74.74 equals opposite over adjacent, and adjacent in this case is 5. So we multiply both sides by 5. These two cross out, and the opposite side is 5 times 74.74 tangent. And that's going to give us 18.32. So the opposite side is 18.33, sorry, whatever units. Okay, sorry about that. What time is it? Well, it is 10:20. It should be done soon. Okay, again, so this is 50, 90, 1950 is 140, which makes this angle 40 degrees. To find the missing sides now, we can use, so let's base it off 50, okay? So let's just use 50 as our base angle. So according to 50, this would be called my opposite side. This would be the adjacent side. This would be obviously the hypotenuse because it's opposite the 90-degree angle. Okay, so what do we need to find? The sides, right? So in order to find the sides, I need to use something. So anything that uses the opposite, because the opposite is the only thing that I do know as far as sides go. So I know the opposite, the angle. So opposite and hypotenuse, I can do that. So sine of 50 is opposite, which is 21, over the hypotenuse, which I don't know. We call that h. Okay. So this one, it just, what we can do here is multiply this side by h, multiply this side by h, right? This goes away, that goes away. So now we have h times, shouldn't be, looks like a decimal, h times sine of 50 equals 21. We're going to divide this by sine of 50. So instead of doing that, what I'm going to do is going to rewrite this. H equals sine 50 equals 21. Much better. Now I divide both sides by sine 50. Sine 50. And that's going to give me my hypotenuse. So 21 divided by, it's going to give me that the hypotenuse is, in this case, 27.41, again, no units. 27.41. Let's just leave it at that. Units, whatever the units are. Okay, so now I need to find the adjacent. So I need to find something with adjacent, and so the only one that has adjacent is TOA or cosine. Cosine has adjacent and hypotenuse, and tangent has opposite and adjacent. Doesn't matter because I have all the values. So so let's use tangent, because so tan of 50 equals opposite, which is 21, over the adjacent, we'll call it a. I don't know what it is. Again, multiply both sides by a, first of all. So we're going to get a tan of 50 equals 21. And then we're going to divide both sides by tan of 50. So this just tan of 50. That crosses out. And our little a is 21 divided by tan of 50. That's going to give us a equals 17.62 units. The adjacent is 17.62. Okay. And I think find the missing sides and angle. Again, the angles are pretty easy to find. Didn't I just do that? Same problem. So GG you don't have to do. So this one, again, 90 plus 31 minus 6, and then divide that, subtract that from 180, and you find the missing angle. So 58.4. This angle here is 58.4. Remember, a triangle has a total of 180. So doesn't matter which one we use. So let's use 58.4. So 58.4, this would be the opposite side. This would be the adjacent side. This would be the hypotenuse. Okay. So let's find the opposite. So let's find for something that uses the adjacent and the opposite. So TOA, and the only thing that uses adjacent and opposite is TOA. So tangent of 58.4 is opposite, which I don't know, over adjacent, which is 7. Multiply both sides by 7, and the opposite side is 7 times 58.4 tan. That's give us 11.38 rounded. So the adjacent is 11.38. And keeping with that, we now need to find the opposite. Right, we found the adjacent. So something that uses adjacent and opposite will be hang on a second, something's wrong. The opposite is 1138, sorry. We're on the wrong side. This is 1138. Okay. So now I need to find the hypotenuse. So anything that uses the hypotenuse, so or ka uses sine and cosine uses hypotenuse. And do I have the adjacent? Yes, I do. Do I have the opposite? Yes, I do. So it doesn't really matter who we use. Let's use sine. So sine of 58.4 degrees is the ratio of the opposite, which is 11.38, over the hypotenuse. So this, we multiply both sides by h first, right? And that gets us this, 11.38. And then we divide this by sine of 58.4. And divide this by sine 58.4. That goes away. H is, the hypotenuse is 11.38 divided by 58.4 sine. Are we doing sine? Yes, we are. That's going to give me 13. The hypotenuse is 13.36. So the hypotenuse is 13.36, and that sort of makes sense because it has to be the longest side. Okay. And we have these two more. Okay, so we just find the missing angle. So what uses, so again, so katoa. So according to this angle, in reference, in terms of this angle, from the perspective of this angle, this is the opposite. This is the hypotenuse, and this is the adjacent. So we want to find the angle. So we want to find the angle, that angle, and we want to use the hypotenuse and the adjacent because those are two values that I know. So what uses the adjacent, the hypotenuse, will be cosine. So cosine of, let's call this theta here, an angle that I don't know, is the ratio of the adjacent, which is 39, over the hypotenuse, which is 42. So what we can do now is we can divide, so cos 39 divided by 42, it's going to give us 0.9285, and I'm going to leave that answer in my calculator. I'm still not done. I have to now multiply. I want my angle, right? Because that's what I want to find, the angle. So I got to get rid of that cos. So multiply by -1, cos -1, and cos -1 over here. So these two go away. Theta's left over. So now you're gonna, that's already in your calculator, 0.9285, etc. You just got to simply find the cos of -1 function, press it, and you're gonna get an answer. So angle theta is 21.79 degrees. 21.79 degrees. Okay. We have the last one. So the last one, we want that angle. So based on that angle, this is the adjacent side. Adjacent, and this is my hypotenuse. And this is my opposite, right? From the point of view of that angle. Let's call that theta again. So to find that angle, I want to use two values, right? Obviously two values that I do know. In this case, the opposite and the hypotenuse. That has to be sine. So sine of theta, right? The ratio, okay, so an angle theta, an angle that I don't know, has a ratio of 26 over 43, right? The ratio of the opposite side of the hypotenuse, 26 over 43, which as a decimal, we write it as 26 divided by 43. 26 divided by, now I know why people like big calculators. It's 0.60465, etc. So I'm going to leave that in my calculator. So again, I just changed that fraction to a decimal format, right? So now let's get rid of that sign. So let's multiply this by sine of -1, which makes this go away. On the other side, it doesn't go away, but theta is left over, and 0.60465, etc., etc. Sine -1 means that the angle is 37.20 degrees. So this angle right here is 37.20 degrees. Oh, bonus word. It's a sentence. It's only the three of us. Okay? And that's that. And hopefully this got recorded.